Alright, section 4.6, we're continuing our integration by substitution, but we're also going to include our trig in this as well. And we're going to talk about the integration of the 6 trig functions. We know a couple of them, and we can use actually those couple to be able to come up with the other ones. However, if you remember the rules, then like everything else, if you remember it, you don't have to worry about coming up with it and devising it yourself. So, as we look at these integrations, the first two we know, the integration of sine of a function of an angle is equal to the negative cosine of that angle as long as it's a single variable. Integration of cosine is equal to the sine. The ones that we have not studied at this point yet are the integration of tangent, cotangent, secant, and cosecant. So the integration of tangent is the negative natural log of the cosine of u plus c. Cotangent is the natural log of the absolute value of the sine of u plus c. Secant of u is the natural log of the secant u plus tangent u. And cosecant of u is the negative natural log of the absolute value of cosecant u plus cotangent u. And again, if we don't remember the sine or the tangent and cotangent ones, those are pretty nice and easy ones to come up with once we find and we know the sine and cosine, as we're going to see in this first example. So here I'm asking you to integrate the sine of theta over the cosine of theta d theta. And I would expect most all of us to know that the sine of theta divided by cosine of theta simplifies to just the tangent of theta d theta. And the integration of tangent of theta from our list up here is going to be the negative natural log of the absolute value of the cosine of theta, plus our c, of course. Now, what if we don't remember this? What can we do to help ourselves? Well, what if we let u, back to that u substitution, u equal, and which one will we let it equal, sine of theta or the cosine of theta? Recall, we've seen this type of problem before, which we didn't know which one to take the u to be, because the derivative of sine is cosine, the derivative of cosine is negative sine. So very, very close to each other. But recall also we would like to have this in polynomial looking form. That is, everything in our numerator. So if I were to bring this cosine of theta to the numerator, there I've got a negative exponent, don't I? So that's going to then determine generally what my u is going to be. Recall that u is generally going to be that quantity to the exponent that we have. So we're going to let u equal the cosine of theta. So the derivative of cosine is negative sine of theta d theta. Now if I look at my substitution, I'm going to have the integration. I can't use the negative, so I have the negative I'm going to pull out just like it's a constant being multiplied to. And then we have our sine of theta d theta is going to go away for our du. And we're going to bring our cosine of theta out as our u to the negative first. So I have the negative integration of u to the negative first du. Well, what is that? Well, u to the negative first may look a little better if we looked at 1 over u. And 1 over u, we should remember, is the natural log of the absolute value of u plus c. But our u is actually the cosine of theta. So we have the negative natural log of the cosine of theta plus c. So we have the answer here, which is, look at that. We just had it right here. So again, we can remember these rules, or we can use some u substitution to be able to come up with what those values are. So if we give you the integration of cosecant of 2x dx, remember we want a single variable to be our angle. So we're going to do a u substitution, and u is going to equal that 2x. Du then is going to be 2 dx. We can't use the 2, so we're going to divide that over. We have 1/2 du equals dx. So now I'm going to integrate. Again, I have 1/2 times that, so I'm going to have a half on the outside of my integration symbol of cosecant of u du. And remember again, from our list, we have the integration of cosine or cosecant of u. So that's 1/2 times, we actually don't need the parentheses there, but we'll put them in there anyway. Negative natural log of the absolute value of cosecant of u plus the cotangent of u plus c. And we can go and replace our u with 2x. So we get a negative 1/2 the natural log of the cosecant of 2x plus the cotangent of 2x and our absolute value plus c. And that gives us our integration. Here we have 5 tangents of 5x dx. Again, I'm going to limit my u, be that angle measure that I want. Du then is going to equal 5 dx. That's kind of nice because I have the 5 dx in this case, so I don't need to do any more solving for dx. So I here have the integration of the tangent of u du. If we remember the tangent of u, oh, I do know that one, don't I? It's the negative natural log of the absolute value of the cosine of u, which is u is 5x, and our absolute value plus c. And then our last one, I just want to do a quick definite integration, just to kind of get you through that as well, but nothing that we haven't seen before. Well, maybe we haven't seen before. 1 plus tangent squared, the square root of that. The first thing we should see is that that is a trig identity. That equals the square root of the secant squared of x, doesn't it? All right, so then we're looking at the integration from 0 to pi over 3 of the square root of secant squared. So let's talk about that square root of secant squared. If I square root the square, or square root, I end up with just what we're taking the square root of. But recall, this can be the positive or negative, so we need the absolute value of that. So we're looking at the absolute value of the secant of x dx. Could pose as a problem, a little trouble for us, but our interval is from 0 to pi over 3. And from 0 to pi over 3, the secant of x is always going to be positive. So we really don't have to worry about that absolute value in there. So we're just looking at the integration from 0 to pi over 3 of the secant of x. That, again, is going to be one of our trig identities. So the secant integration is going to be the negative, or natural log of the secant of x plus the tangent of x plus, we don't need our plus c, do we? We have a definite integration. 0 to pi over 3. All right. So now we can go ahead and plug in our pi over 3 minus plugging in our 0. So we have the natural log of the absolute value of the secant of pi over 3 plus the tangent of pi over 3 minus the natural log of the absolute value of the secant of 0 plus the tangent of 0. So now we can go ahead and think about what these values are. So the secant of pi over 3. I don't remember what secant of pi over 3 is. What can I do with secant? I know that is the cosine, don't I? Cosine of pi over 3. Well, again, what's the cosine of pi over 3? Cosine of pi over 3, go back to our unit circle, and there's pi over 3. It's a 60-degree angle, remember? So we're coming over a little and then up a lot, so that cosine is going to be 1/2, isn't it? So I have that natural log of 1 over 1/2 plus, oh, good heavens, the tangent of pi over 3. What's the tangent of pi over 3? Well, we have 1/2 here. This is going to be radical 3 over 2 then. Then we take our sine divided by our cosine, so we get radical 3 over 2 over 1/2. So that gives us radical 3 minus the natural log of the absolute value secant of 0. So if we have 0, that's out here, that's the point 1, 0. So the secant, again, is 1 over cosine of 0. So cosine of 0 is 1. So 1 divided by 1 gives us 1, doesn't it? Plus, and here we're going to look at the tangent of 0. So that's 0 divided by 1, which is 0. So we have the natural log of 1 divided by 2, which is going to be, or 1 divided by 1/2, which is 2, plus the square root of 3, minus the natural log of 1. Natural log of 1 is, 0. So we end up with the natural log of, since 2 and radical 3 are both positive, when we add them together, we don't necessarily need that absolute value anymore. So we get the natural log of 2 plus radical 3. Put those into the calculator, but then If this was a calculator question and we did all this work, I would say, well, why are you doing all that work? We would have simply put this into our calculator and been done a long time ago. So that's going to be my exact value that I'm looking for on a multiple test quiz or test of that sort. So that gives you kind of an idea of our trig rules. Again, remembering sine and cosine, we've been working with those quite extensively at this point in time. However, tangent and cotangent we can come up with. Secant and cosecant, not normally used. You may see them. Probably going to be a calculator type of question where you're just typing it into the calculator knowing that the cosecant is 1 over sine and secant is 1 over cosine. So that gives you an idea of what we're looking at. If you have questions, let me know. Good luck, enjoy. Happy integrating.